Okay, how do we put everything together to be able to solve or begin to solve multi-step equations? So this one still has one number, one thing on one side, right? But there's a little extra going on here. So before we can start to do the do undo method, what we might want to think about doing is dealing with this distribution first. Okay. Now we could try the do undo method with this 8 here, but I will say oftentimes it's going to be really a lot simpler to combine like terms. Let's actually look at it both ways. So if I look at this as 8 plus 2 times x plus 1 equals 30, what I see is, well, let's try do undo. Let's see how we like that. So do, undo, down, up. So if I think about the do undo, well, first I would add 1, then I would multiply by 2, and then I would add 8. Okay, well, that seems reasonable. Minus 8, divide by 2, minus 1. Seems reasonable. I take my 30 and I'm going to undo all this stuff to get that magic number. So 30 minus 8 is going to be 22. 22 divided by 2 equals 11. And 11 minus 1 equals 10. Okay, well, let's see if we do it a different way if we get the same answer. So I'm going to take the same equation, and what I'm going to do is I'm going to ignore the equals 30, and I'm just going to do distributive property and combine like terms first. So what I'm going to focus on is cleaning this up, okay? So if I look at 8 plus 2 times x plus 1, I notice this can be distributed. So if I think about my box, I have 2x and 1. 2 times x is 2x. 2 times 1 is 2. But I've still got this 8 down here. So I'm going to pull it all down. 8 plus 2x plus 2. And then we still equal 30. I guess we should keep that guy with us, right? And then I notice I've got 2 like terms here. 2x doesn't have a like term because nothing else has an x with it. So 8 plus 2 is 10, and 2x equals 30. Okay, now this is something we're pretty used to doing, right? So I can do my do, undo. And if I do that, then I would multiply by 2, and I would add 10 minus 10 divided by 2. Oops, getting close. And so then I would have 30 minus 10 equals 20, and 20 divided by 2 equals 10. Same answer, 2 different ways. I think we could probably argue this way is nicer, okay? So when we have an original equation that doesn't have a term with an x in it, it's okay to use do undo. But no, we could clean up this side first. Okay, let's try another problem that looks a little different. So this problem, what I notice is we've got something with an x there, right? So what are we going to do with that? Well, what we have to do is we've got to clean this up. We have no other way to go about this other than cleaning up first. Because if I try and think about my do undo, I've got 2 do's with my x that I would have to be really, really careful with, and it's not going to work. So gotta clean. So when you've got an x out here, we've got to clean up. So I'm going to take this and I'm going to start by cleaning this. Okay, negative 2 times 7x is negative 14x. Negative 2 times negative 6 is 12. Okay, so I'm going to rewrite my whole equation. That just equaled that. So I'm going to bring down my 12x, bring down my equals 14. I'm going to put this little guy in there. Okay, So now we've kind of got a new equation. Well, what I noticed is I've got some like terms. 12x minus 14x is going to give us negative 2x plus 12 equals 14. I can do that problem. That's a simple do undo. Simple, bad choice of words. It's a one we've practiced, right? None of these are particularly simple. Okay, so do undo. First, I'd multiply by negative 2, and then I'd add 12. Subtract 12, and let's see. Oh, this one's confusing, but the operation is multiply. So I'm going to divide by negative 2. So 14 minus 12 equals 2, and 2 divided by negative 2 equals negative 1. And there's our answer. This one's pretty challenging, right? Good luck.